Our aim is to determine the battery internal resistance of this battery. To do that, we're going to take these measurements shown here. The first measurement we're going to take is just of the EMF of the battery. For that, we need a multimeter, which we're going to set as a voltmeter by turning this dial to 20 volts maximum. And all we need to do is to measure the potential difference across the two terminals, as you can see here in the circuit diagram. Then for this diagram, we're going to connect that battery into a circuit. This circuit diagram is obviously more complex. We're going to use the battery. We're also going to use a battery clip. You can see we need a 220 ohm resistor, red, brown, 220 ohms. And then we're going to use our multimeter, sometimes as a voltmeter and sometimes as an ammeter. Now, before we actually build these circuits and take these measurements, let's just think about what do we need to find out, how are we going to measure it, why do we need to know that, and how are we going to use it for our aim to determine the internal resistance of a battery. So what do we need to do to determine the internal resistance of a battery? To do that, we need all this information here. Some of this information we can get from direct measurement, and some of the information we can only calculate from other measurements. So we need to think that through. The current strength we can measure using an ammeter. The voltage across the load we can measure using a voltmeter. The load is this 220 ohm resistor. So once the 220 ohm resistor is part of a circuit, if we place a voltmeter across it, then we'll be able to get the voltage across the load, V load. The resistance value of the 220 ohm we can measure with an ohm meter if we like. We can just read it off there. It says 220. It will probably not be exactly 220 ohms, so maybe it's not a good idea to actually take it as 220. Perhaps we should rather measure it. We can also calculate it like this, because if we know V load and we know current strength, then we can calculate resistance. So we can get the value of capital R, load, by calculation or by measurement. This voltmeter here measures the potential difference across the battery when current is flowing through the battery. In other words, when there's a complete circuit that the battery is part of. Remember that this entire symbol there is actually the battery. Normally we wouldn't draw the internal resistance, but we are just to make it explicit. So V cells we can measure. It will be the same value as V load. So it's not really necessary to measure both V cells and V load, but we can if we want to. What about EMF? We cannot measure EMF in the circuit shown in this diagram. In other words, when the battery is part of a complete circuit. But we can measure EMF by simply placing the probes of the voltmeter, when the voltmeter is on of course, across the terminals of the battery. EMF is the potential difference across a battery when no current flows through the battery. So we can measure EMF. We are left with internal resistance, which is what we're actually trying to find out. That's the aim of this experiment. And V internal resistance. These two we cannot measure. We can only calculate them. So how do we calculate them? Using this formula. EMF is equal to V load plus V internal resistance. V load is I capital R. Capital R is the load, external resistance. I capital R gives you V load. Plus I small r. Small r is the value of the internal resistance of the battery, which is what we're trying to find out. So here I've rewritten the top equation. Notice the top and the bottom equation are the same equation, just in different formats. But I've rewritten the top format into this table. EMF is equal to V load plus V internal resistance. Remember, EMF we can measure. How do we measure it? We just place the voltmeter straight across the battery with no current flowing through the battery. That's equal to V load we can measure. How do we measure it? It's the same thing as V cells. So we can place the voltmeter either across the battery when current is flowing through the battery. In other words, when the battery is part of a complete circuit, or we can measure it across the external resistance, the load. Both of those values will be the same as one another, and that is V load. The internal resistance we cannot measure. But can you see that we can calculate it? Because if we know these two, we can solve for this one because there's only one unknown. Just rearrange the equation and you can solve for V internal resistance. Now remember, V load is the same thing as I capital R. So here in the table, I've unpacked V load into I and capital R. And let's look at them separately. And V internal resistance is I small r. So again, I've unpacked that in the table. V internal resistance is equal to I small r. So let's think about these. EMF, we've already said we know how to measure that. Now V load, yes, we can measure it directly. But what about if we rather want the component? I, yes, we can measure that. Current strength, use our ammeter. Capital R, load, yes, we can measure that. We don't even need to measure it because it's given to us here on the bands of the resistor. But we maybe don't want to trust that because of manufacturing error. But we can use an ohm meter, we can measure that. V internal resistance is equal to I small r. I, yes, we can measure using the ammeter. Small r, no, we cannot measure it. We can only calculate it. But can you see? No problem, because it is the only unknown in this formula. We can measure all the others and then just put all the values into the formula and solve for the unknown, small r. So we're going to use this table to collect our data. As we do the measurements, we're going to put the data into this table. So let's just make sure we understand what's going on in this table before we take our measurements. We're going to write the EMF value over here. We're going to measure the V load and put that value over here. We know that EMF is equal to V load plus V internal resistance, and we know both the EMF and the V load. So we can solve for the V internal resistance. How? Just rearrange this formula and you get V internal resistance is equal to EMF minus V load. So we're just simply going to transfer this value there and this value there, and then we know what V internal resistance is. Current strength, we're going to measure that with the ammeter, and we're going to write it in there and there. That will be in milliamperes, so we need to convert that into amperes. How? By dividing by 1,000. Then our current strengths will be in the unit ampere. The resistance we can get in many different ways, but let's maybe calculate it. It's really optional. How do we calculate it? We know that R equals V over I. In other words, the resistance here is equal to the voltage across it over I, the current strength through it. So V load over I. Then we'll find out what the external resistance is, and it should be 220 ohm, although it may differ a bit because of manufacturing error. And then all that we have left to find out is what we actually are trying to find out in the first place. Small r, battery internal resistance's value. Again, we know that R equals V over I. The battery internal resistance, small r, is equal to the V across that internal resistance, V internal resistance, divided by the current strength through. Current strength through is the same for all the points in the series circuit, so there's only one value for that. So we simply substitute, and then we will have our answer of what we were trying to find out in the first place, the resistance of the battery internal resistor for this particular battery now.